welcome to Deeksha Karnataka YouTube channel, and today I am going to bring you something very special for all the KCET aspirants. So some of you are complaining that sir, our KCET course was left in the middle. So don't worry, we will bring the all important PYQs from all the chapters, remaining chapters, as well as the chapters that we have covered. We will discuss them again. So today I am going to discuss very important PYQs of KCET from the chapters ray optics and wave optics. So let us start with today's session. First, obviously, we will first 15 questions are from ray optics, next 15 questions are from wave optics. So total 30 questions I will be discussing today. So don't miss out on this lecture. This will be very important for all of those who are preparing for your KCET exam. So now let's start. A ray of light passes from vacuum into a medium of refractive index small n. If the angle of incidence is twice the angle of refraction, then the angle of incidence in terms of refractive index is. Very interesting question. So a ray of light passes from vacuum to a medium. So here a ray of light which is passing from vacuum to a medium. So that means obviously the ray will bend towards the normal, and this is the angle of refraction, this is the angle of incidence. What is mentioned is that the angle of incidence is twice the angle of refraction, right? This is given in the question. Now refractive index of vacuum is 1, refractive index of this medium say n. Okay, that is given in this question as well. So what you have to do, you have to find the value of I in terms of this n, right? Interesting. So how to do that? We will use our very old tried and tested Snell's law, which says that 1 into sine I equals to n into sine r. This is the generalized form of Snell's law. If this is n1, this is n2, then generalized Snell's law says that n1 sine I equals to n2 sine r, right? This formula. Now here n1 equals to 1, n2 equals to n, and we got this relation. Again, it is mentioned that I equals to 2r. So what we will be doing, we will calculate the, so 1 into sine 2r equals to n sine r, right? Or what else we can do is we can take 2 sine r cos r equals to n sine r. What we have done, we have just simply break this 2r sine 2 theta into 2 cos theta, sine theta 2 into sine theta into cos theta, right? Now sine r gets cancelled, so we got 2 cos r equals to n, or cos r equals to n by 2, or r equals to cos inverse n by 2. Right? So we have calculated r. The question does not ask you to find r, but they ask you to calculate I. So what we will be doing, we will put back that value of r that we have calculated back into this equation. So we get 2 into cos inverse n by 2. So correct answer is 2 into cos inverse n by 2. So option A is correct, right? So you have to identify the correct answer after solving. Easy solution, not a difficult question. Now next question. A convex lens has power capital P. It is cut into 2 halves along the principal axis. Further, one piece out of the 2 halves is cut into 2 halves, the perpendicular to the principal axis as shown in the figure. Choose the incorrect option for the reported lens pieces. Now the shortcut to answer this question is that when you cut a lens along the principal axis, okay, the power remains unchanged. So if the power of this lens is P, then power of this half, this bottom half, will also be P, okay, because radius of curvature still remains same. Only thing that happens is that the brightness of the image that you can see decreases. Otherwise, this half will always give you the same power, same focal length. Okay, it is just a half length. Even though it's a half length, power and focal length does not change, it remains the same. Okay, whereas if you cut it along the axis of the lens, okay, this is the axis of the lens, if you cut it along this side, the radius of curvature changes and power becomes p by 2 and focal length becomes twice the focal length. Okay, so this will also be p by 2 and focal length will be 2f. Okay, remember this. This can be proven using your tried and tested lens maker's equation, but we are not going into that detail. This is the fact that you can remember. This is easy to remember as well. So when you cutting along the axis of the lens, you get power half. If you cut along the principal axis, you get power same. Okay, so now what is the question? Let's check. Choose the correct option for the reported lens pieces. Power of lens L3 is equals to P by 2. Power of L3 equals to P by 2, correct statement. Power of L1 equals to P. Power of L1 equals to P, correct statement. Power of L1 equals to P by 2, obviously not correct. So this is an incorrect statement. This should be our correct answer. Power of L1 is P. Power of L2 is P by 2. Power of L2 is P by 2, correct statement. Okay, so be careful when you are choosing. Correct, incorrect question can sometimes be tricky. Now next question. The image formed by an objective lens of a compound microscope. Objective lens means the first lens which is there. Okay, objective lens of compound microscope or refracting telescope, they always form real and inverted as well as magnified image. Okay, so it will be real and enlarged image by objective. So correct answer is option 1 or option A. Okay, remember this. Objective of a refractive telescope or a compound microscope, no matter what objective, will always form a real image. Okay, sometimes student get confused. So objective always forms real image. Eyepieces generally form a virtual image. Okay, so that you can see it through the eyepiece. But objective is the first lens that will always form real image, and eyepiece will further enhance the size of the image and create a virtual image. Now next question, before going into the next question, just wanted to remind you that currently we have started our PU2 crash course for all those students who want to score well 90 plus in all the subjects, and definitely you should consider this PU2 crash course, and the price is very low, only 999. Okay, so 999 is the cost of your one shoe. Okay, or 1 day or 1 month, your pocket money of 1 month, you can purchase this course. This is very essential if you want to do well in your KCET exam, because you all know that 50% of the weightage of your KCET comes from your PU2 result. Also, you should remember that last year the students got very good marks in KCET exam, but their rank was much below because their PU2 result was not that good. So PU2 result does matter, and you should not forget that, and you should obviously consider our PU2 crash course. It's a very well thought out crash course for all of you. Now let's continue with the lecture. If R and R1 denotes the angles inside the prism. So here we have R and R1. Okay, so R and R1 are the refractive angle of the prism. The prism having an angle of prism 50 degrees. So this is 50 degrees. Coinciding that during the interval of time from t equals to 0 to t equals to t. Okay, so r, small r, varies with r equals to 10 degree plus t square. During the time r1 will vary with time as. So interesting question. Very easy question actually. So they have given you R and R1, and they said that R varies according to this equation. So if R is varying according to this equation, how R1 will vary? Don't worry, we have the equation that says that angle of the prism is equals to R1 plus R2, right? If this angle is R1, this angle is R2, then this is the formula, right? In this particular question, A is given as 50 degrees and R1 is given as R, R1 is given as R, and R2 is given as R1. Okay. Further, this R is given as 10 degree plus t square. So 50 degree equals to 10 degree plus t square plus R1. So now you can calculate R1, which will be 50 degrees minus 10 degrees minus t square, that is 40 degrees minus t square. So correct answer is 40 degree minus t square, that is option 3. Now next question. The final image formed by an astronomical telescope is the final image. Final image is always virtual and enlarged. Okay, virtual, inverted and enlarged. So correct answer is virtual, inverted and magnified. Virtual, inverted and magnified. So correct answer is option D. So as I mentioned, final image is basically when it is formed by eyepiece. Eyepiece always forms virtual images, magnified and inverted. Okay, and that's what we observe in microscope as well as telescope. Only their principle is slightly different, their working is slightly different based on the position, based on the focal length, but otherwise the image formation is always same in case of objective as well as in case of eyepiece. Okay, objective for both of them forms real images, whereas eyepiece or final image is always virtual for both of them. Next question, if the angle of minimum deviation is equal to the angle of prism for an equilateral prism, then the speed of light inside the prism is. Very interesting question. Suddenly from angle of minimum deviation they are asking you speed of light. So what is the relation? So first of all, we know that the refractive index of a medium of a prism is given by sine A plus delta m divided by 2, right? Delta m is the minimum angle of deviation divided by sine A by 2, right? And for an equilateral prism, we know that A equals to 60 degrees. Now here in the question it says that it is same as the angle of minimum deviation. So delta and A both are 60 degrees. Now let us put the values over here. So we get n equals to sine 60 plus 60 divided by 2 divided by sine 60 by 2, that is, so in the top we get sine 60 and in the division we get sine 30. Sine 60 is what? Sine 60 is root 3 by 2 and sine 30 is half. So we get the refractive index to be root 3. So sir, why did you calculate refractive index? We are asked to find the speed of light, because refractive index for any medium is given as n equals to c by v. C is the speed of light in vacuum, which is already known, 3 into 10 to the power of 8. So we can calculate v to be c divided by n. That's why we calculated refractive index. So first step to calculate refractive index, next step is to calculate the speed. So 10 to the power of 8 divided by root 3. So we can normalize it and we can say it will be root 3 into 10 to the power of 8 meter per second. So root 3 into 10 to the power of 8 meter per second is the speed of light in that medium, right? Interesting question, isn't it? Next question. A luminous point object O is placed at a distance capital 2r from a spherical boundary separating two transparent media of refractive indices n1 equals to 4 by 3 and n2 equals to 3 by 2 as shown. where capital R is the radius of curvature of the spherical surface. If N1 is this and R is 10 centimeter, the image obtained at a distance P equals to. So what will be the image obtained in this particular case, right? So N1 is given by 4 by 3, N2 is given by 3 by 2, the R is given as 10 centimeter, the object is placed at a distance of 20 centimeter. Now what formula we'll be using? We will be using the formula for curved surface, which says that N2 by V minus N1 by U equals to N2 minus N1 by R. Now how to remember this? How to remember this? In general, this may not be always, but in general what happens is that when a ray of light is passing like this, okay, object is in the region of refractive index N1 and image is in general in the refractive index of N2. So what happens is that so V is the image distance, U is the object distance, so N2 by V minus N1 by U. Normally in lens equation we see 1 by V minus 1 by U, but in this case because V is located inside N2, so it will be N2 by V minus N1 by U, okay, and equals to N2 minus N1. If you remember this, then it will be also easy to remember N2 minus N1 divided by R. Now let us put the values. N2 is 3 by 2 divided by V minus N1 is 4 by 3, right? 4 by 3. 4 by 3 divided by 2R equals to 3 by 2 minus 4 by 3 divided by 2 divided by R, not 2R, R. Right? So if we put this, you can calculate the value of V from this equation. Okay, do not put the value of R yet. We will do that in due time, but first let us calculate this one. So 3 by 2 minus 4 by 3. So 6, 9 minus 8, that is 1 upon 6. Okay, so we get 3 by 2V minus 4 by 6R equals to 1 by 6R. 1 by 6 in the top divided by R, that means 1 by 6R. Right? Clear? So now what we will be doing? 3 by 2V equals to 1 by 6R plus 4 by 6R. One more thing that I forgot is that U is negative. U is negative, right? U is always on the left hand side, that means U will be negative, so you have to put negative sign over here, so it will be positive. Okay, sign convention will apply in this particular case as well. Don't ignore the sign convention. So you will get 1 by 6R minus 4 by 6R, or 6R is the LCM. 1 minus 4, that is 3 by 6R, or 1 by 2R, that is 1 by 2R. Okay, so now V will be equals to 3 by 2 into 2R. 2 cancels, that is 3R, and there is a negative sign also. So negative sign you cannot ignore, because 1 minus 4 is minus 3. Right? So it will be minus 30 centimeter. Now what is the meaning of minus 30 centimeter? Minus 30 centimeter means the object is located on this side, okay, on the negative x-axis, right? Minus 30 centimeter represents a distance on the negative x-axis, that is in the first medium itself. Okay, so we will get the image at 30 centimeter in the rarer medium. This is rarer. 4 by 3 is rarer than 3 by 2. So if you calculate, you will get 1.33, this will be 1.5. So this is a rarer medium. So 30 centimeter in the rarer medium, that is option A is correct. Okay, this is slightly lengthy question, but solvable if you know how to solve it. Formula and sign convention, both you have to be careful about. So the question on ray optics, so what is the learning? Formula is important as well as the sign convention, both are important. Next, an equiconvex lens of radius of curvature 14 centimeter is made up of two different materials, left half and right half. So we have two different materials. Left half is made with 1.5 refractive index, right half is made with 1.2 refractive index, respectively, as shown in the figure. If the point object is placed at a distance of 40 centimeter, calculate the image distance. So first of all, this is a combination of lenses. Okay, so this side has say focal length f1, this one say a focal length f2. If we can calculate f1 and f2, then the capital F, that is the equivalent focal length of this combination, will be given by f1 f2 by f1 plus f2, right? This is the formula for two lenses in combination. So this formula we will be using. First we have to calculate f1 and f2. So first, obviously 1 by f1 equals to n minus 1, n1 minus 1, 1 by r minus 1 by infinity. Why? So if you see this diagram, so this is the radius of curvature of this surface, which is positive. The other surface is this one. So basically you can consider this consists of two lenses. One is this one, another one is this one. Okay, so first when you are calculating the focal length of this lens, we will take the other side to be infinity, right? So that's why this is to be infinity. In the second case, second surface, this first radius of curvature will be infinity and the second one will be minus r. Second one will be minus r. Okay, clear? Now radius of curvature is given 14 centimeter, so we will put that, and this one is 1.5. so 1.5 minus 1 into 1 by 14. Okay, 1 by infinity is 0. So we get this as 0.5 divided by 14, that is 1 by 28. Okay, so f1 turns out to be 28 centimeter. What about f2? 1 by f2 equals to n2 minus 1, okay, 1 by infinity minus 1 by minus r. Okay, so this is the this side of the lens. As I mentioned, first surface is this one, infinity. Second surface is this one. This is also, this is minus r. Okay, this is a radius of curvature, so radius is on this side, so that's why it is minus, and that's why you put minus over here. So 1.2 minus 1 into 1 by r, or 0.2 into 1 by 14, or it will be 1 by 70. So f2 equals to 70 centimeter. Okay, now we will go back to this equation and calculate the equivalent focal length, which is turns out to be 28 plus 70, 28 into 70 divided by 28 plus 70. That is 28 into 70 divided by 98. That is, let's calculate. 4 sevens are 28, 7 ones are 7, 4 sevens are 28. So 7 tens are 70, and 7 twos are 14, 2 twos are 4. So we get 20 centimeter. So the combined focal length of this lens is 40 centimeter. So you can replace this system using only one lens of focal length 20 centimeter. So if this is the 20 centimeter lens, and if you place an object at a distance of 40 centimeter, what is this? This is basically the distance of 2f, right? So if the object is placed at 2f, where do we see the image? Image is also formed at 2f, so image will be formed exactly at 40 centimeter on the other side. Okay, so the image distance will be 40 centimeter as well. So after all this calculation, you realized the object distance is equal to image distance because the object is placed at the focal length, right? Even though it's a lengthy question, but answer is not that difficult. Next question, a point object is moving at a constant speed of 1 meter per second along the principal axis of a convex lens of focal length 10 centimeter. The speed of the image is also 1 meter per second when the object is at dash centimeter from the optic center of the lens. So here we have a lens, okay, and the object is moving at a speed of 1 centimeter per second, and the image will also move at 1 centimeter per second when the object distance and the image distance are equal. Okay, this is only possible when object distance and image distance are equal. At that point only they will move with the same speed. So when does this happen? When the object is actually, that is equals to 2f, then image distance will also be 2f. In that case only we observe that u equals to v, and then only we see that they will move at same speed. So the focal length given here is 10 centimeter, so the image must be at a distance of 20 centimeters. So answer here will be 20 centimeter. Clear? So this is a typical KCET level easy question that should not take a lot time to solve. Next, for a given pair of transparent media, the critical angle for which the color is maximum. Okay, so critical angle. So first of all, what is critical angle? So if you forget that when ray of light is traveling from denser medium to rarer medium at a particular angle IC, the ray of light passes grazing through the medium separating the two media, and that is called the critical angle. This angle of incidence is called critical angle. And also we know that the refractive index of this denser medium with respect to the rarer medium is given by 1 upon sine IC. Okay, for this given pair of media, the refractive index is given by 1 by sine IC. So this is number 1. So we can say that sine IC is equals to 1 by n, or IC is proportional to 1 by n. Why so? Because it's a sine angle. As the angle increases, the value increases. So if n is increasing, the sine value is decreasing. That means it's basically giving you a inverse proportional relation. So we calculated the IC equals to 1 by n. Excuse me. Next is, what is the relationship with n and with the color? So each color has different wavelength. Each color has different wavelength. Okay, so refractive index of a medium is inversely proportional to wavelength. Higher the wavelength, smaller is the refractive index. Okay, so that's why red light scatters the less, because the refractive index is very low. So red light do not scatter too much. Okay, that is one of the reason behind this. Now, so refractive index is inversely proportional to wavelength. That means higher the wavelength, smaller will be the refractive index. So IC, we can say that IC is directly proportional to wavelength. IC, inverse of inverse is direct. So enemy of your enemy is my friend, right? So in that principle, this is also inversely proportional, this is also inversely proportional. So these two must be directly proportional. Okay, these two must be directly proportional. So IC must be directly proportional to alpha. That means higher is the wavelength, we will have higher critical angle. So who has highest wavelength amongst this? The red light has highest wavelength. Okay, and among this, violet has smallest. Next is blue, then is green. You remember the Viv gear, okay, VIBGYOR. So R has the highest wavelength, and on top violet has the smallest wavelength. So we can say that the critical angle will be maximum for red light. Critical angle will be maximum for red light. Remember this concept. Based on this concept, we have seen many questions in KCET, not beyond 2023, but it came in the past, it might come again in future. So this is a very interesting, important concept. Next, for a point object, which of the following always produces virtual image in air? So which two things that produces virtual images in air? One is concave lens, another one is convex mirror. So let's see which is given over here. Plano-convex lens. Plano-convex lens always can produce real image, can produce virtual image, but it does not produce virtual image always. Convex mirror. Convex mirror for a real object always produces virtual images. So correct answer is convex mirror. Biconvex lens, concave mirror, they all can produce real as well as virtual. So that's why only answer is convex mirror. Next, an equiconvex lens made of glass of refractive index 3/2 has focal length f in air. It is completely immersed in water of refractive index 4/3. The percentage change in the focal length is. So let us see. So we know that focal length from Lensmaker's equation. So Lensmaker's equation is another very common equation that is coming in every year. So focal length when it is in air, then the refractive index is f. So n minus 1 into 2/r. For a equiconvex lens, you can directly write, this is a shortcut, so you can directly write 2/r. You don't need to do 1/r1 minus 1/r2, then put the sign convention, then take them equal. So you don't need to do that. You can directly write this formula. This is the shortcut formula for focal length for equiconvex or equiconcave. So 3/2 minus 1 into 2/r, or half into 2/r, or it will be 1/r, or focal length comes out to be r. So initially the focal length was actually equal to the radius of curvature. Now what happens? You immerse this entire system into water of refractive index 4/3. So what will be the new focal length? The new focal length, say f dash, can be written again using the Lensmaker's equation. Only thing that will change over here, you are only using glass. Now what you have to do, n glass divided by n water minus 1. Everything else remains the same. Everything else remains the same. Now we will put the value of n glass as 3/2 and n water as 4/3 minus 1 into 2/r, or it will be, what is the value of this? 3 will go up, so 9, and this 2 will come down. 4 into 2 is 8 minus 1 into 2/r, or it will be 1/8 into 2/r, or it will be 1/4r. Right, 1/4r is the 1/4r is the 1/f dash. So f dash must be equals to 4r. So this is the new focal length. Initially focal length was r. The final focal length is 4r. So what will be the percentage change in focal length? So first of all, let us calculate the change in focal length. Change in focal length is final focal length minus initial focal length, that is 3r. Now what is the percentage change? Percentage change is given by delta f by f into 100%. Right? Delta f is 3r, initial was r, so 3r by r into 100%, that is 300%. So correct answer is 300% increase. 300% increase. It is not decreasing, it is only increasing. So we can say 300% increase. Clear? Now next, consider a glass slab which is silvered at one side and other side is transparent. Given the refractive index of the glass slab to be 1.5, if a ray of light incident at an angle of 45 degrees on the transparent side, the deviation of the ray of light from its path comes out to be. So it is an easy question. So here we have a glass slab and one side is silvered. Okay, a ray of light which incident at an angle 45 degrees. Okay, it falls over here, it goes there, then it comes out like this. Now if you ignore the glass slab, you can simply say that this is a simple reflection, only the reflecting plane is slightly lifted, so it is slightly up, but in this case the angle of incidence is 45. This is parallel, okay, this is parallel, so this is alternate angle. Similarly, this will be also be 45 degrees according to law of reflection, so this will also be 45 degree. So what is the deviation? The deviation is basically this angle and this angle, that is, this is the angle of deviation. So deviation is given by 180 degrees minus 2y. So no matter, even if it is a glass slab, in case of glass slab the deviation formula remains same, that is 180 degrees minus 2 into 45 degrees, that is 180 minus 90, that is 90 degrees. Okay, so the deviation is 90 degrees. Does not matter, the slab is given as a eye wash. Okay, so even if the slab was not there, the deviation would be same 90 degrees. Even if you have added the glass slab, the deviation will still be 180, still be 90 degrees. Focal length of a convex lens will be maximum for, again, focal length related to wavelength of light. So as I mentioned, this concept is common. It came in KCET multiple times. So we know that 1 by focal length equals to n minus 1 into 2 by r. Right? Now if you ignore this 1 minus 1 term, okay, we can say that focal length is inversely proportional to the refractive index. Okay, again, refractive index is inversely proportional to wavelength lambda. So enemy of your enemy is my friend. So from that logic, focal length must be proportional to lambda. So higher the wavelength, higher will be the focal length. So again, the red light is the answer. But remember that not always red will be the answer. There are some instances where blue or violet was correct answer. So in this case, red light is the correct answer. That means red light has highest focal length. So, okay, remember one important fact: in color related questions, the answer will be red light or violet or blue. Okay, other colors will not affect much. Okay, other colors will not affect much. Only the thing is, red light or violet light are the important part to remember. A ray of light passes through an equilateral glass prism in such a manner that the angle of incidence is equal to the angle of emergence, and each of this angle is equal to 3/4 of the angle of the prism. The angle of deviation is, interesting question, easy question. So angle of incidence equals to angle of emergence. That means this is the case of minimum deviation. That is, delta is minimum, right? Also we know that I plus E is given by, so I plus E is given by A plus delta M. Right, in general it is not delta M, but in this particular case it is mentioned that I is equals to A, so you can say that this is delta M. Even though it is not required, only formula you need to answer this question is I plus E equals to A plus delta. Now here it is given I is equal to E equals to 3 by 4 into A. Okay, so 3 by 4 into A means 3 by 4 into A plus 3 by 4 into A equals to A. Okay, so that is equals to A plus delta. Now 3 by 4 plus 3 by 4 is what? It will be 3 by 2 into A equals to A plus delta, or 3 by 2 A minus A equals to delta. Okay, or we can say that this is equals to half A equals to delta. So delta equals to half of A, that is half of 60 degrees. Why 60 degrees? Because it is mentioned equilateral glass prism. So equilateral glass prism means all sides are equal. That means the angles are, all angles are 60 degrees. So angle of the prism will also be 60 degree. So we can say that the angle of deviation will be 30 degrees in this particular case. Now we will move into the wave optics chapter, right? We have already solved the questions from ray optics. Now let us move on to the wave optics chapter. If AB is incident plane wave from front, then refracted wave front in n1 is greater than n2. So there is a biconvex lens which is given, and a plane wave front is incident on a convex lens. So when plane wavefront incident on a convex lens, what happens? After refraction, they converge at this. Okay, it is mentioned that n2 is greater than n1, so this is n1, this is n2, right? So if it is opposite of that, n1 is greater than n2, then it would have been diverging. Okay, it would have been diverging, but because it is a n2 is greater than n1, that means it's a converging lens. So converging lens means the ray will converge at the focal length, and the what will be the nature of this wavefront? The wavefront will be like this, right? This is the center, and it will be a spherical wavefront. So from center the ray, the wavefront will be like this, because it is going to converge. So remember this represents converging wavefront. This represents converging wavefront. Okay, and opposite of that, that is this way, this represents a diverging wavefront. Okay, so in this particular case, the wavefront will be like this. So option D is correct answer. Slightly tricky, not time taking, but conceptually important. Okay, conceptually very important. As you can see, you can answer this question if you know it. If you don't know it, if it is something else, then you have to understand what is happening with the situation over here, and based on that you can answer the question. Next, the total energy carried by light wave when it travels from a rarer to a non-reflecting and non-absorbing medium. Okay, non-absorbing, non-reflecting medium, the energy should remain constant. Okay, energy should remains the same. In here it will be remains the same, because if it is not absorbing, not reflecting, that means total energy must be conserved. That is the conservation of energy. In Young's double slit experiment, an electron beam is used to produce interference of width beta 1. Now the electron beam is replaced by a beam of protons with the same experiment setup and the same speed. The fringe width obtained is beta 2. Then what is the correct relationship between beta 1 and beta 2? This question is slightly tricky. This depends on some concept of your wave matter duality chapter. Okay, in wave matter duality chapter, we know that the wavelength of a matter wave is given by h by p. Okay, h by p, right? The wavelength of a matter wave is given by h by p, where h is the Planck's constant and p is the momentum of the particle. Now here it is mentioned that beta 1 is due to electron and beta 2 is due to the proton. Both of them have same speed, but momentum, will it be same? So for electron it will be Pe. Now as you know that electron has a very smaller mass, okay, the momentum of electron will be much smaller. Momentum of electron will be much smaller, whereas for a proton, the momentum will be much higher. Okay, now what is the relationship with this, with fringe width? So fringe width is actually proportional to wavelength lambda. Okay, exact relationship you do not need to know, but fringe width is proportional to lambda. So beta 1 by beta 2 must be equals to lambda 1 by lambda 2. Okay, so if you put that relation, so lambda E by lambda P, let me write it like this, that will be easier to understand. Okay, beta 1 by beta 2 is lambda of electron divided by lambda of proton. But as you can see, this is inversely proportional, so it will turns out to be a momentum of proton divided by momentum of electron. Okay, so momentum of proton is obviously higher because mass of the proton is higher. So you can write it like this: mass of proton into speed divided by mass of electron divided by speed. Same speed, but mass is different. So that means this quantity is greater than 1. This quantity is greater than 1. So this is say 1000, this is say 1. So 1000 by 1 is definitely greater than 1. So from there we can say that beta 1 must be greater than beta 2. Okay, so beta 1 must be greater than beta 2. So correct answer option D. Okay, fringes do we do obtain fringe for electrons and protons, okay, because they behave like waves, right, matter wave. So that's why we observe diffraction and interference for these as well. Interesting question, slightly mixed concept question, and you might not be able to answer it if you do not know both the chapters, dual nature of radiation and matter, and also the concept of wave optics. Let's move on. Now this type of question is very common till 2024. Almost every year there was a question based on this concept. In 2025 it was not there, but maybe in 2026 again they will repeat similar questions. Okay, 3 Polaroid sheets are coaxially placed as indicated in the diagram. Pass axis of the Polaroids 2 and 3 make 30 degrees and 90 degrees with the pass axis of Polaroid sheet 1. If I naught is the intensity of the incident unpolarized light entering the sheet 1, the intensity of the emergent light through sheet 3 is. Okay, so here we have a ray of light I naught which is entering through the first Polaroid. Okay, and what will be the intensity of the light after it coming out of the first Polaroid? So when the light ray emerges out of a Polaroid, the intensity directly drops by 2. The intensity directly drops by 2. This is first Polaroid, so as soon as it enters the Polaroid, the intensity drops by 2. Now from now on we will apply Malus law. Okay, from now on, suppose this intensity is say I2, this intensity say I3, so I2 and I3 we have to use Malus law. This is I1 we have calculated as I naught by 2. This is the basic property. As soon as an unpolarized light enters a Polaroid, the intensity drops by 2. Okay, now so what will be I2? I2 will be I1 cos square theta. So what is theta over here? This was 0 degree, this is 30 degrees, so theta is 30 minus 0, that is 30 degrees. I1 is I naught by 2 and cos square 30 degrees. So what is cos 30? Cos 30 is root 3 by 2. So root 3 by 2 whole square, that is 3 by 4. Okay, so it will be 3 I naught by 8. So I2 will be 3 I naught by 8. Now next is what is the angle? Again we have to apply Malus law. So I3 will be equals to I2 cos square theta dash. So what is theta dash? Theta dash here is I2 is 3 I naught by 8. So this is a step by step problem. You cannot solve it directly. So you have to solve it step by step. 3 I naught by 8 into cos square 90 minus 30. So this one is 30, this one is 90. So what is the relative angle between them? Relative angle between them is 90 minus 30, that is 60. So cos 60 is 3 I naught by 8. Cos 60 is half and its square of that will be 1 by 4. So we get 3 I naught by 32. So this is the correct intensity, 3 I naught by 32. So option B is correct for this question. Now next, when light propagates through a given homogeneous medium, the velocities of primary wavefronts are lesser than those of secondary wavelets. Primary wavefronts are greater than or equal to those of secondary wavelets. Primary wavefront and wavelets are equal. So this is the correct answer. Primary wavelet and wavefronts are equal always. That is the Huygens principle. So option C is correct. An unpolarized light of intensity I is passed through two Polaroids kept one after the other with their planes parallel to each other. The intensity of the light emerging from the second Polaroid is I by 4. The angle between the pass axis of the Polaroid is. So again, as I mentioned, similar questions came every year. So we have two Polaroids. Okay, planes are parallel but pass axes are different. Okay, so first we have an unpolarized light intensity I passes through this one and this one, same angle theta. Okay, so this angle is theta. Now what will be the what is this angle theta that we have to calculate? So first of all, what will be the intensity of the light after it passes through the first Polaroid? The intensity of the light after it passes through the first Polaroid will be directly be I by 2. Clear? It will always be the case, no matter whatever is the question, unpolarized light passing through a Polaroid, intensity will be half. What about this one? This one will be I2 equals to I by 2 cos square theta. This is the Malus law. This is Malus law, right? The intensity with which it is entering, and it is already polarized. So whatever is the angle between the polarizing Polaroid and the analyzing Polaroid, then we get the angle as cos square theta. Okay, and this I2 is given as I by 4. So I by 4 equals to I by 2 cos square theta. Okay, I cancels, 2 cancels, so we get cos square theta equals to half, or cos theta equals to 1 by root 2, that is theta equals to 45 degrees. Okay, so the angle must be equals to 45 degrees. Clear? Now next question. In case of Fraunhofer diffraction at a single slit, the diffraction pattern on the screen is correct for which of the following statement? Central dark band. So Fraunhofer diffraction and diffraction are same. Okay, the diffraction that we have studied, Fresnel diffraction is not part of the syllabus, it was never there, but Fraunhofer diffraction means normal diffraction. Central dark band having uniform brightness, central dark band having alternate dark and bright bands, central bright band having dark bands on either side. So in diffraction pattern, always remember the central band is always bright, and then we have dark and bright pattern. Okay, central band is central band or central fringe is always bright, then we get some dark and then bright and dark and bright, like that. So central bright band having dark bands on either side is the correct answer. Okay, one more thing. If you consider this one is more appropriate. Central bright band having alternate dark and bright bands of decreasing intensity on either side. So this tends to be the correct answer, because this is not only two dark bands, there are some other dark bands, some other bright bands as well. So if you read this statement, this is more accurate, more appropriate for this case. When a compact disc CD is illuminated, a small source white light, colored bands are observed. This is due to diffraction. This is due to diffraction. Next, for a light diverging from a finite point source, wavefront are parabolic, wavefront are cylindrical, intensity of the wavefront does not depend on the distance, the intensity decreases in proportion to the distance squared. So let's see. So when a light is actually propagating, okay, the wavefront is spherical from a point source, and the intensity decreases with the square of the distance. Okay, so suppose this is intensity 1, this is intensity 2, okay, this is D1, this is say D2. Okay, remember that intensity is always proportional to the square of the distance, inversely proportional to the square of the distance. Okay, so this is how intensity decreases. That's why the light, when it is traveled to a very long distance, it does not remain as bright, its brightness decreases with the distance. Okay, so intensity decreases with the square of the distance. A slit width is illuminated by red light of wavelength 6500 angstrom. If the first diffraction minimum falls at 30 degrees, then the value of small a is. Okay, so first of all, what is this question is about? We have a diffraction pattern, we have a screen, and we observe this diffraction pattern. Same side. Now it says that the first dark band is actually falling at an angle 30 degrees. So we can take this 30 degree angle as the half width. We can take this angle as half width of the diffraction pattern, and we know that A sin theta, okay, A sin theta equals to n lambda. A sin theta equals to n lambda. So we can write that A sin theta is 30 degrees, n is first order, and lambda is 6500 angstrom. Angstrom means 10 to the power of minus 10. Okay, or A into half equals to 6500 into 10 to the power of minus 10, or A equals to 65 into 2 is 130, so 130 000 into 10 to the power of minus 10. Okay, so we can write this as 1.3 into 10 to the power of minus 6 meters. Okay, 1.1234. So 1.3 into 10 to the power of minus 6, that is 1.3 micron. Micron means micrometer. Micron means micrometer. So correct answer is option B, 1.3 micron. Next, which of the statements are correct with reference to single slit diffraction pattern? Fringes are of unequal width. Yes, this is true. Fringes are of equal width. Both cannot be true. This is wrong. Light energy is conserved. Yes, light energy is always conserved. Intensities of all bright fringes are equal. No. So they are unequal width and unequal brightness. Central maximum is bright, and as we go up or down, the brightness decreases. So only option 1 and 3. Only option 1 and 3 are correct. So option A is correct. Three Polaroid sheets P1, P2 and P3 are kept parallel to each other such that the angle between the pass axis of P1 and P2 is 45 degrees. That between P2 and P3 is also 45 degrees. If unpolarized beam of light of intensity 128 watt per meter square is incident on P1, what is the intensity of light coming out of P3? So here we have P1, P2 and P3. Okay, so P1, P2 and P3. Okay, the angle between P1 and P2 is 45. The angle between P2 and P3 again 45. Okay, and the light intensity, say I incident on this. What will be the incident coming out of this? I by 2. What will be the light that is coming out of this? Say I2, and say after this, say I3. Okay, so what will be the intensity I2? I2 will be I by 2 cos square 45 degrees, right? So I by 2 into 1 by root 2 whole square, that is I by 2 into 1 by 2, that is I by 4. So this is the intensity of the light I2. What about I3? I3 is I by 4 into cos square 45 degree again, right? This angle is also 45 degree, so we get I by 4 into half, that is I by 8. Now what is I over here? So I given here as 128, so I3 will be 128 divided by 8. Okay, I by 8. So now let us cancel 64, 4, 16. So this is 16 watt. So 120 watt becomes 16 watt per meter square. Correct answer is option A. In Young's double slit experiment using monochromatic light of wavelength lambda, the intensity of light at a point on the screen where path difference lambda is k units. The intensity of a light at a point where path difference is lambda by 3 is. So in Young's double slit experiment, we know that the resultant intensity is given by 4I0 cos square phi by 2. So this formula is very, very essential. The derivation can be coming as well, but the formula is very, very essential and you have to remember it. Now here this phi is actually the phase difference. Phase difference. But if you see the question, they have given the path difference. So what is the relationship between phase difference and path difference? So it is 2 pi by lambda into delta x. Delta x is the path difference. Delta x is your path difference. Okay, so now put the values 2 pi by lambda into lambda, that is 2 pi. So initially it is 2 pi. Okay, what is the final case? So this is phi 1 where the intensity given as k. Phi 2 where we have to calculate 2 pi by lambda, and the path difference here given as lambda by 3, that is lambda by 3. Okay, so it will be lambda cancels, 2 pi by 3. Okay, now we will go back to our equation. So initially the intensity I1 was 4I0 cos square 2 pi, phi is 2 pi, 2 pi by 2. Okay, what is 2 pi by 2? 2 pi by 2 is pi. So what is the value of cos pi? Cos pi is minus 1. Pi means 180 degrees. Okay, so cos pi is minus 1, but there is a square term, so we can write 4I0 into minus 1 whole square, that is 4I0. So this is the initial intensity. What is the final intensity? Final intensity I2 equals to 4I0 cos square. Okay, now we have the angle 2 pi by 3. So 2 pi by 3 divided by 2, because there is a by 2 over here, right? So we get 2 cancels, we get 4I0 cos square pi by 3. What is pi by 3? Pi by 3 is 60 degrees. What is the cos square 60 degrees? Cos 60? Cos 60 is half. Cos square 60 degree is 4I0 half square, that is 4I0 into 1 by 4. 1 by 4 and 4 cancels, and we get this is equals to I0. Now this value is given as k. This value in the question given as k. So what is I0? I0 will be simply k by 4, right? So the intensity will be k by 4. Okay, something interesting, new question, new style of question. A plane wavefront of wavelength lambda is incident on a single slit of width a. The angular width of the principal maximum is, okay, the single slit of width a, wavelength is lambda, so a sine theta equals to n lambda. Okay, now theta is, if it generally we consider theta is small, so a into theta equals to n lambda, or theta equals to n lambda by a. Okay, now for central maximum n equals to 1, so it becomes lambda by a. Okay, lambda by a is angular width, half angular width, sorry, this is the half angular width, and they ask you the total angular width. Total angular width actually 2 theta, which is given by 2 lambda by a. This is a formula you can remember, or you can derive it using this formula as well. So it is 2 lambda by a is the angular width of diffraction pattern. To observe diffraction, the size of the obstacle should be lambda by 2, where lambda is wavelength, should be of the order of the wavelength. To observe interference or diffraction, the slit width will always be of the order of the wavelength. Okay, remember this. The slit width will always be of the order of the wavelength. Now this is the end of this lecture. So I will be back with more PYQs of KCET, and we will keep preparing for KCET exam, and we are trying our best to help you to during your KCET preparation as well. So don't forget to subscribe to our channel, and obviously give the thumbs up if you like this video, and share this video with your friends so that they can also study along with us. I'll be back. Till then, bye.